The skeletal system comprises about 20% of our body mass. Most of this weight comes from the presence of bones, which can be split into two large categories, the axial skeleton and the appendicular skeleton. The appendicular skeleton includes the appendage girdles and their limbs, which contain long bones. Long bones can be found in the upper and lower limbs of the body. However, not all limb bones are long bones. Carpals, tarsals, and patella are excluded from long bones. The clavicle is also considered a long bone. Long bones have a wide range of functions. Long bones, especially those of the leg, are load-bearing and support our body weight. The arm, forearm, and leg bones act as levers to exert force. In that regard, they are essential to skeletal mobility and manipulation of the environment. The red marrow found in the matrix of trabeculae contains hematopoietic, or blood-forming tissue. Here, 100% of blood platelets and erythrocytes and 60% to 70% of leukocytes are formed. The yellow marrow of the diaphysis contains a deposit of adipose tissue. Here, the fat can be broken down to provide energy to the body. Long bones have a unique gross anatomy that sets them apart from the other types of bones. Surrounding the exterior of the long bone is the periosteum. This protective membrane is held in place by collagen fibers, known as Sharpie's fibers, which provide channels for blood to flow in and out of the bone. The diaphysis, or shaft of the long bone, is met on either end by the epiphysis, or rounded ends of the long bone. The diaphysis can be thought of as two layers, the cortex, or outer layer, made of compact bone, and the inner medullary cavity, made of spongy bone. Inside this cavity, yellow bone marrow can be found between the trabeculae of the spongy bone. In infants, red bone marrow is also found in the medullary cavity. A vascular membrane known as the endosteum lines the inside of the medullary cavities. The epiphysis are the rounded ends of the long bone. It has an outer layer of compact bone and an inner region of spongy bone, much like the diaphysis. In adults, red bone marrow is found in the spongy bone of the epiphysis. Between the diaphysis and the epiphysis is a region of hyaline cartilage known as the epiphyseal plate or epiphyseal line. In undeveloped humans, this is the site of longitudinal bone growth, and the epiphyseal plate is very thick and discernible. As the human grows, the plate becomes thinner and fuses with the rest of the bone, at which point longitudinal bone growth ends. On both epiphyses, articular cartilage is found to form a joint, such as the elbow or knee. Fractures in long bones in children can lead to complications. A complete fracture, such as a spiral, transverse, or oblique fracture, can damage the epiphyseal plate and hinder further growth as the child ages. Long bones can be affected by a variety of diseases. Two different congenital diseases, such as rhinitis fetalis annularis, is the congenital enlargement of the epiphysis of long bones. Another congenital disorder is rhinitis fetalis micromelica, where the long bone has a deficiency in the growth. The leg bones are particularly at risk from diseases such as osteoporosis or rickets. Because these diseases weaken bones, the load-bearing structures of the leg can easily become bent out of shape when they lack proper nutrients. In conclusion, long bones are a very important part of the appendicular skeletal system. They have important functions and unique structural characteristics that separate them from other types of bones found in the body.